Everyone, welcome to a new tutorial of analog electronics. We are studying feedback amplifiers, and in the previous lecture we were able to explain the two types of feedback that we have in amplifiers. In today's lecture, let us look at the principles of feedback amplifiers. Now, for an ordinary amplifier, that is an amplifier without feedback, the voltage gain is given by the ratio of the output and the input voltage. So, the input voltage Vi or V1 is amplified by a factor of A to the value Vo of the output voltage. So, we are saying, in other words, that for amplifiers without feedback, the voltage gain, assuming that we have gain A, is given by the ratio of the output voltage Vo to the input voltage Vin. If you want to get now the value of the output voltage, so this tells us that the output voltage is given by the gain of the amplifier multiplied by the input voltage. Now, for amplifiers without feedback, their gain are known as open loop gain. So, the gain A is known as open loop gain because it has got no feedback energy. Now, suppose a feedback loop is added to the amplifier. Now, let us assume you have got this kind of circuit. You have the input energy here. You have the output. This is amplified with gain A. So we are saying that this one is just known as the open loop gain. Now, if a feedback loop is added to the amplifier, so adding the feedback network here, so we can say that this one is the feedback circuit. Let us carry the necessary connections. So this is the feedback energy that we are just adding. Now, then a fraction beta, can call this one beta. A fraction beta of the output voltage is applied to the input. So beta of the output voltage Vo is applied to the input voltage, which therefore becomes the new input voltage. The new input voltage will be Vi plus or minus beta V O or prime. That means that it will be the input voltage plus or minus depending on whether the feedback voltage is in phase or out of phase with the input energy. Now, for example, if we assume the positive feedback, the input voltage, so for positive feedback, the input voltage will be Vi plus beta Vo prime. And when it is amplified for A times, you can say when amplified several times, let's call it A times, then the total energy of the amplifier will be A multiplied by the new input energy, but now with the feedback. So we are putting prime because we are including now the feedback. That is how we are saying it is Vo prime. So in other words, we are saying that the feedback energy Vf is given by beta Vo prime. So if we say that A multiplied by the input energy plus beta Vo prime will now give us the output energy when we have applied again on it. That is how you are saying it is prime. We can factor out this one. We have got Vo here. We have of course Vo. With the further mathematical analysis, you achieve Vo prime into bracket 1 minus beta A, which will be A Vi. So the amplifier again A with the feedback is given by A prime is equal to Vo over Vi, which will be equal to A over 1 minus beta A. So this will be the case of an amplifier where we applied positive feedback. The gain with the positive feedback will be the gain without feedback A over 1 minus beta A. So we are saying that this one is the gain of an amplifier where we have applied positive feedback. For negative feedback, the gain for negative feedback will be, of course, Vo over Vin, which will be A over 1 minus beta A. And this one will be A over 1 plus beta A. This one will be the gain for an amplifier that has employed negative feedback. So the term beta A is called feedback factor, where beta is known as So beta is also known as feedback ratio. It is known as feedback ratio. So the expression 1 plus or minus beta A is known as loop gain. It is known as loop gain because we have either employed a positive feedback or a negative feedback to the amplifier. So the amplifier, again, A prime is referred to as closed loop gain. So it is generally referred to as the closed loop gain because of course its gain has been obtained after the feedback loop has been closed. We have another term that we call sacrifice factor. So sacrifice factor S, abbreviated as S, is given by gain without feedback or over gain with the feedback. In other words, this kind of equation is used to determine the amount of gain the amplifier has sacrificed after it has employed the negative feedback, because we said for negative feedback we reduces the gain. In other words, we sacrifices the gain in order for us to get the advantages of other factors like increased stability, reduction of noise, and also reduction of distortion. So the sacrifice factor is used to determine the sacrifice that or the amount we have sacrificed in order for us to achieve other factors in order for our amplifier to operate well. Thank you for this lecture. Of course, I thank you for your time. Today we have discussed on the principles of feedback in amplifiers, and we have been able to know what is closed loop gain and open loop gain, and we have also known the feedback equation for an amplifier which has positive feedback and the feedback equation for the amplifier which has negative feedback. Let us meet in the next lecture. Goodbye.